Welcome to the hot seat. Today in our explainer, we're doing something a little different and honestly a lot of fun. We're running a simulation. Imagine you've just made it to the final, high-stakes technical interview for a senior AI engineer role. You're sitting right across from the hiring manager. Now don't worry, they aren't going to ask you to invert a binary tree on a whiteboard. Instead, they're going to grill you on the core engineering trade-offs in modern generative AI systems. We're going to build your production-ready mental models by breaking down the absolute hardest architectural decisions in Retrieval-Augmented Generation, or RAG. So let's get right into it.
Think of this as your interview schedule for the day. First up, designing your chunking strategy. Second, trade-offs in prompt caching. Third, architecting with MCP. Fourth, isolating production failures. And finally, number 5, observability over private thinking.
Okay, let's dive straight into this. Round 1, designing your chunking strategy.
Imagine I'm your interviewer. I look down at your resume, fold my hands, look right at you, and ask, what is the best chunking strategy for your RAG system? Now, I need to warn you right off the bat. In a senior engineering interview, simply shrugging and saying, well, it depends, is a failing answer. You absolutely need to show that you have a deterministic framework for making this exact decision.
Let's step out of the hot seat for a second so I can give you the core mental model you're going to need here. Chunking isn't merely about taking a meat cleaver and splitting text into random pieces. No, it is a fundamental retrieval-unit design decision. A chunk is the precise unit that you embed, index, retrieve, re-rank, and eventually pass to the model. It has to be small enough to match a specific user query, but large enough to actually preserve the meaning needed to answer the question accurately.
And mapping this out brilliantly illustrates how you should actually answer my interview question. You don't just pick a universal fixed token size like 512 tokens and call it a day. You map specific data formats to specific starting strategies. If you have a general prose wiki, you're going to start with recursive chunking with some overlap. Dealing with a code repository? Well, then you need an abstract syntax tree, or AST, to preserve the actual logic. If you're handling dense legal policies, you'd use a sentence window to get a precise hit, and then expand the parent context so the model actually understands the surrounding rules.
If you want to absolutely ace this portion of the interview, mentally bookmark this 30-second golden answer. You confidently state, chunking is the retrieval unit design. I select it from document structure and query behavior, not a universal token value. You explain that you benchmark structured chunking against a fixed token baseline, and you always preserve metadata. That right there is how a senior engineer answers the question.
All right, take a breath. You passed round 1. Let's move to round 2, trade-offs in prompt caching.
The interviewer leans in and throws a total curveball question at you. Your prompt cache keeps missing and costs are spiking. What invalidates an anthropic cached prefix? The stakes here are real-world API bills. If you don't know how the model provider handles their cache, you are going to burn through your engineering budget fast. Literally nobody wants to be the engineer who accidentally bankrupts the startup on a random Tuesday.
To survive this question, you need to quickly explain the anthropic caching hierarchy. It builds in a very strict order. First comes tools, then the system prompt, and finally, the messages. If you change a tool schema at layer 1, it instantly invalidates that layer and absolutely everything after it. If you change the system prompt, you nuke the system and the message cache.
You know the biggest trap developers fall into here? It's shockingly simple. Putting dynamic data, like the current time or the user's active memory, inside their static prefix. Doing that destroys the cumulative hash, meaning you pay full price for every single request instead of reading from the cheap cache. You absolutely must keep dynamic runtime cards in an uncached suffix at the very end of your prompt. Also, be incredibly careful with the 20-block lookback trap. If the gap between your previous cache write and your next request's breakpoint exceeds 20 blocks, the system simply won't find it.
When it's time to summarize your response, you hit them with this polished answer. Anthropic prompt caching is cumulative prefix caching. Changing an earlier level invalidates later cache layers. Current time and fresh memory remain in a small dynamic suffix. Boom. You just showed you understand the massive contrast between stable, expensive prefixes like rarely changing tool schemas and massive static documents versus volatile dynamic suffixes that hold per-turn nudges.
Let's move on and see how this builds right into our third round, architecting with MCP. So, MCP is the new standard for connecting AI models to data sources. I'm going to put on my tough interviewer voice again to test if you actually understand the underlying dependencies of this protocol. In MCP, does the protocol automatically force the model to read a resource before calling a tool? If you're unsure about this, draw a strict dividing line in your head right now. Tools are model-invoked, dynamic actions. Think calling an API to check a deployment status. Resources, on the other hand, are application-driven, readable context, addressed by a URI, like reading a markdown deployment policy. So the answer to the interviewer's trick question is a firm, hard no. MCP does not automatically enforce a read-before-action dependency. Forcing a model to read the policy resource before executing the deployment tool is an application orchestration choice. It is not a protocol feature.
You seal the deal in this round by stating clearly that MCP servers expose tools, resources, and prompts. But notice the absolutely critical security distinction for remote servers here. You combine OAuth-based authorization with server-side policy checks. Because authentication alone is completely insufficient. Authentication simply proves who is calling. Authorization proves they are actually allowed to press the button.
Excellent work so far. You're in round 4, isolating production failures.
Here is your high-pressure debugging scenario. The interviewer says, the agent hallucinated in production. Did the model invent facts, or did the retrieval step fail? Let me let you in on a little secret. If your first engineering instinct is to rush in and start tweaking the system prompt, you have failed this round. You cannot solve every failure by blindly changing the prompt.
A true senior engineer systematically isolates the failure layer using a strict debugging sequence. It's like a funnel. You have to ask, did the correct document enter the candidate set? If so, did the correct chunk enter top K? Did re-ranking preserve it? Did the model actually use the evidence faithfully? Was the context just too small or noisy? You meticulously isolate the exact layer before you even think about touching a single line of code.
Now, what's genuinely fascinating here is how this logic entirely dictates your evaluation strategy. When you're using an LLM as a judge to automate this kind of debugging, the judge is completely 100% useless without the correct minimum input matrix. Look at faithfulness for a second. This is your core anti-hallucination metric. To judge faithfulness, you cannot just feed the judge the user's question and the generated answer. No way. The judge absolutely must have the retrieved context chunks to verify if the claims are actually supported by the evidence.
So here is your polished 30-second answer to summarize your evaluation philosophy. For offline evaluation, I use a curated dataset. For online evaluation, I sample production traces and apply rubric-based judges. Relevance needs the question and answer. Faithfulness needs retrieved context. You clearly define the strict boundary between offline evaluation gates and online observation.
You've made it to the final round. This is a rapid-fire mindset check. Observability over private thinking.
The interviewer looks right at you and asks one final thing. Are you tracking hidden reasoning or observable execution? The correct answer here requires you to firmly reject a very common myth. You tell them that you rely on frameworks to capture the observable execution trace. You track request metadata, retrieval timings, tool calls, and precise token usage to isolate regressions. You do not chase the illusion of reading a model's private chain of thought. You instrument the observable path, and with that perfect answer, you've survived the hot seat. But as you go back to your own architecture today, leave yourself with this final, crucial question. Are you actually engineering a reliable, observable system, or are you just crossing your fingers and hoping the AI thinks like you do? Thanks for joining us on our Explainer today.